3.2, verifying identities. So helpful strategies of verifying identities. We're going to work on one side of the equation, usually the more complicated side. Keeping in mind the expression on the other side is our go. So we want one side to end up equaling the other side. And if that happens, then we have an identity. Some expressions can be simplified quickly if they are rewritten in terms of sine and cosine only. To convert one rational expression to another, we're going to multiply the numerator and denominator of the first expression by either or numerator. So, okay, so what that is talking about is our basic math that we've been doing whenever we simplify our fractions. Okay, so I'll let y'all read the rest of that. So what we're going to do is just let's jump in there and start doing some work. And I apologize, I got the answer already highlighted, but let's talk about why that is the correct answer. It says identify the expression that completes the identity. So they gave us one side and they said, well, what equals the other side? Well, we have 4 choices to choose from. However, let's do a little bit of work to determine that. I noticed that this is a binomial times a binomial. And if I say, okay, let's go ahead and multiply this out. Let's say that we take our first here times our first. Well, what does that give me? It gives me cosine squared beta. Now let's take our cosine times that negative cosecant. Oops. All right, plus, now let's do this one. So now we got cosecant beta times cosine beta plus, and then our last, right? So we got a positive cosecant times the negative cosecant. All right, let's clean this up. I got cosine squared beta. My middle terms here, this is just going to be a negative cosine beta cosecant beta. And then this next one here is going to be the positive value of it. What happens to it? It goes to 0, right? This is like saying you have $1 or you're in the hole $1 and you actually had $1 and you turn around and spent it. You're in the hole. So it's 0, not in the hole. I'm sorry. It just goes to 0. That's 0. Now I'm going to add, whoops. Let me clean this up. And y'all are back with me, right?
Yes, I'm here.
Yep.
Yeah.
Yes.
Okay.
Yeah.
Okay. And now I got the cosecant times the negative cosecant. So now I got a negative cosecant squared beta. So I got cosine squared beta minus cosecant squared beta. And now we're trying to figure out what does that even equal? I mean, does it give me anything that I can work with? Well, if I go through the Pythagorean identities and look for something there, maybe it will give me something. Could, however, we already got our answer here. So y'all see where we got it? That's how come B is correct.
Are you recording this?
I am.
Okay.
Okay, so that was all it is. We got that. And we're going to do more of the Pythagorean identities here in a little bit. All right, example 2 says find the statement that completes the identity, just like what we did above. So now we're given the sine of x minus cosine x all divided by cosine x. If I rewrite this, let's just rewrite it and see what we get. So I get sine, and when I rewrite, what I mean by rewriting is I'm going to break this apart. Y'all remember in algebra, you can have b plus or excuse me, A plus BI divided by C. We can rewrite it as A over C plus BI over C. Let's do the same thing here. Sine X over cosine X minus cosine X over cosine X. Well, what happens? We got cosine over cosine, that gives me 1. So now I got sine X over cosine X minus 1. If we go back to our identities, what does that give me? Well, actually, before I even go that far, what is cosine or sine X over cosine X? That's tangent X minus 1. We can go back to our identities. However, this is all we need here. And that was it. So example 3 says find the product and simplify your answer. So we got a binomial times a binomial. So I have secant x times secant x. So that's secant squared x. And then I have secant times that 1. So it gives me a positive secant x. I got the negative 1 times that secant. So it gives me a negative secant x. And then we have negative 1 times positive 1, which gives me a negative 1. My middle here goes to 0, leaves me with secant squared x minus 1. And whenever you go back to our identities in section 3.1, we find out that secant squared x minus 1 is equal to tangent squared x. So our answer is tangent squared x.
I have a question for example 2.
Okay.
How did you decide that was tangent -1? Is it because sine over cosine is tangent?
Correct.
Okay.
I just kept simplifying down till I couldn't simplify no more.
Okay, makes sense.
Okay, so let's do our next one. Excuse me. So now we have this basically it could be a binomial times a binomial, but we can rewrite it. You can use a formula or the shortcut method you learn in college algebra. Excuse me. But this here is just telling me that I have the same parentheses times itself twice, right? That's all it is. So you got 2 options here. We can use the full method, distributed method, whichever, and multiply 2 binomials together. Or we can use the shortcut method that you learn in college algebra. And I'm going to use this method here, but I'm going to show you the shortcut for those who likes it. So the shortcut method says that whenever you have 2 binomials multiplied together and in each parentheses, they are identical, same first, same last, same signs, then that means we're going to square the first, double the middle. And what is the middle? The middle is the first, and I left secant off here, guys. Sorry about that. And then we're going to double the middle. What's the middle? The middle is going to be 5 secant times that 2. And then we're going to square the last. So you can use the shortcut method if you want. So what they did, they used this notation. This means we're going to have a squared plus 2 times a times b plus b squared. So if you want to use this method, go for it right now. If not, I'm fixing to show you this other method. I like the other method just because I'm a very visual person. So I'm going to erase this and let's do it. All right. So it says that we're going to take the first, which is 5 secant x times the first and the second parentheses, 5 secant x plus, and then I'm going to take the 5 secant x times that 2 plus, that 2 times that 5 secant x plus 2 times 2. And let's clean it up. 5 times 5 is 25. Secant times secant is secant squared. Plus 5 times 2 is 10. Secant x plus 2 times 5 is 10. Secant x plus 2 times 2 is 4. Now I have these two in the middle that can be put together. So I have 25 secant squared x. 10 plus 10 is 20. Secant x plus 4. And that is it. That's simplifying it. That is finding the product of that. And that's our answer. Any questions?
Can you wait a second?
Sure. And if you use a shortcut, you'll come out with the same answer too.
Okay.
Okay. Our last one for this section. It says prove that this equation is an identity. So we're going to work on one side, proving that the other side, or that it's equal to the other side. And if I can do that, then I know I have an identity going on. I'm going to use the most complicated side. And that would be this one here. So let's do that. I got secant x over tangent x. Well, what do I know about secant x? I'm going to leave it alone. That's what I know. Well, hang on. Let me just backtrack. I don't want to use that method. Let's use this method. We have a subtraction going on. And in order to subtract fractions, we have to have a common denominator. So what I want to do is multiply by the common denominator on each part. And what do I see as the common denominator here? I see that tangent x and secant x is my common denominator. So what I need to do is multiply top and bottom on this one by the secant x. I'm going to multiply top and bottom on this one by tangent x. Now that I've done that, I got secant squared x all divided by, well, let's go ahead and do this, minus the tangent squared x all divided by secant x tangent x. Okay. Now that I've done that, I'm going to acknowledge what's my numerator. Well, what is the numerator? When we go back to our Pythagorean identities, I know that secant squared x, actually I know that tangent squared x is equal to 1 minus secant squared x. Okay. I can also rewrite it as tangent, hang on, I wrote that wrong. When you go back to the Pythagorean identities, what I notice is that we have 1 minus tangent. You know what? Any of y'all have y'all's notes pulled up? Let's see. It's going to be secant squared x minus tangent squared x is equal to 1. Oh, okay. I know what I did. I hope y'all saw what I was fixing to do. So we get this. So I was going backwards. I was wanting to show y'all the backwards method. There's no sense in it though. We can just go straight to this. So secant squared x minus tangent squared x is equal to 1. Knowing that, I can rewrite this numerator as 1. So now I have 1 in the numerator over the secant x tangent x. And when I do that, I'm going to do one more step. I'm going to break it apart. And what do I know about 1 over secant x? Well, I know it's the inverse of cosine x. And 1 over tangent x, I know is cotangent x. So that is my answer. So true, it is an identity. Any questions?
Nope.